These processes include rib forming, roller forming, and isostatic pressing. To build the industry's leading high-capacity crucible, we start with a huge ball of clay graphite material. Large chunks of the pre-mixed material are assembled piece by piece and kneaded and pounded by skilled hands into the specific structure, density, and shape needed for the crucible forming process. For the Noltina 3 metric ton capacity crucible being made here, this hand shaping requires about 4 hours to complete. Next, the crucible mold is lowered over our carefully shaped clay graphite ball, now dusted with graphite to prevent the clay from sticking to the mold. 3 men work together to flip the mold so that the crucible material is now in the bottom as the mold is moved to the rib forming machine. The forming device, called a rib because of its shape, is then lowered into the mold. As the turntable holding the crucible begins to rotate, a hydraulic ram presses the rib into the clay graphite material in the bottom of the mold. It exerts pressure up to 5 metric tons. After the mold is removed and flipped, the crucible is carefully removed. This automated process produces a crucible with a far more uniform shape and density than is possible with hand-forming techniques. Rib-forming small crucibles uses a manual system taking advantage of mechanical leverage to apply the pressure needed to form the crucible in the rotating mold. Roller forming is the production process we use to manufacture Stabil brand silicon carbide crucibles used by customers worldwide. After the mold is filled and closed, a stainless steel roller, here bilge-shaped, is lowered into the spinning mold and pressure is applied, displacing the crucible material and compressing it onto the mold bottom and sides. Roller forming molds and rollers can be changed, allowing the system to be used for making a variety of crucible sizes and shapes. Our roller forming process produces a dense crucible with good thermal conductivity, excellent thermal shock resistance, high mechanical strength and refractoriness, and very high resistance to damage caused by fluxes. And because the roller forming cycle is fully programmed, every crucible produced has identical properties and offers uniform performance. Isostatic pressing, isopressing for short, is a specialized manufacturing process that uses a liquid or gas medium to apply uniform and simultaneous pressure from all directions on a material being compacted. At Morgan MMS, we use this process to make syncarb clay bonded graphite crucibles and ultramelt carbon bonded silicon carbide crucibles. Isopressing produces crucibles with the highest possible density, reduced porosity, and a homogeneous material composition from bottom to rim. We also use this process to manufacture silicon carbide degassing rotors and filling funnels. The key operating principle is to put the crucible material to be compacted between an unyielding steel surface and a flexible surface that will expand or contract in response to the isostatic pressure generated by the press. Accurate positioning of the core is essential before the mold is closed and moved via automated conveyor to the filling station. There, an overhead material dispensing system is used to fill the mold with the clay graphite or silicon carbide material specified for the crucible being made. When the mold reaches the isopress, it is loaded onto a lift that lowers the mold into the pressing chamber, which is filled with water. After the chamber is sealed, the isopressing cycle is initiated. First, pressure is increased via oil pumps until the maximum pressure is reached. Then, after a brief holding period at this pressure, decompression begins in fixed steps until all pressure is removed. At the end of the cycle, the lift returns the mold to the conveyor level, where it is moved to the demolding area, where the crucible is removed from the mold.